Hello children, welcome back to chemistry session. In last session we have discussed about reaction of acids reacts with metals and reaction of bases reacts with metals. In that we have seen in both the experiments hydrogen gas is evolved. In today's session we are going to talk about reaction of metal carbonates and metal bicarbonates with acids. Let us start today's session children. Reaction of metal carbonates and metal bicarbonates with acids. Metal bicarbonates also called as metal hydrogen carbonates. Let us talk about required materials of reaction of metal carbonates and metal bicarbonates with acids. We want the materials like retard stand, which we see in last activity, retard stand. Next conical flask are boiling tube and 2-hole rubber cork and thistle funnel, delivery tube and another boiling tube which contain freshly prepared lime water. These are the required materials of, and we should take acid also, either hydrochloric acid or sulfuric acid or nitric acid, any one. These are the required materials of reaction of metal carbonates and bicarbonates with acids. Let us see the experimental arrangement of reaction of metal carbonates with acids. First we should consider retard stand, and we have to fix boiling tube to the retard stand. The help of clamp should fix boiling tube to the retard stand. This is the retard stand and this is boiling tube. This boiling tube has to be filled with few grams of metal carbonate. Any metal carbonate you can take children. Let us take sodium carbonate. This boiling tube has to be filled with few grams of sodium carbonate. Formula sodium carbonate is Na2CO3. Na2CO3 is an example of metal carbonate. Formula of sodium carbonate Na2CO3. And with the help of rubber cork, we have to close the mouth of the boiling tube. With the help of rubber cork, we are closing mouth of the rubber cork. So this rubber cork has 2 holes children. Through one hole we should insert thistle funnel. Through one hole we insert thistle funnel and we insert delivery tube. We insert delivery tube in another hole children. Through one hole we insert thistle funnel. This is called thistle funnel. What is the use of thistle funnel here? We can add acid to the sodium carbonate by dropwise. So we have to add dropwise acid with the help of thistle funnel. So it has to be filled with acid like hydrochloric acid, dilute hydrochloric acid. So dilute hydrochloric acid is added to the sodium carbonate by dropwise. Now in another hole we place delivery tube. Now this another end of the delivery tube is placed in a boiling tube. This has to be filled with freshly prepared lime water. Formula of lime water CaOH twice. This is the experimental arrangement of reaction of metal carbonates and bicarbonates with acids. First we should take retard stand and this is boiling tube. This boiling tube is fixed to the retard stand with the help of clamp, and this boiling tube has to be filled with sodium carbonate and it has to close with the help of rubber cord which contains two holes. Through one hole we fix the shell funnel, and in another hole we place delivery tube. And the use of the shell funnel is we can add dilute hydrochloric acid dropwise to the metal carbonate, that is sodium carbonate. And another delivery tube we place in a boiling tube which is filled with lime water, that is calcium hydroxide. Now when the reaction has taken place between acid and metal carbonate, that is sodium carbonate and hydrochloric acid, dilute hydrochloric acid. So after some time you notice formation of bubbles in the boiling tube, and the bubbles are passes through the delivery tube and enters into the another boiling tube which has filled with lime water. Then we can notice that the lime water turns to milky white. This lime water turns to milky white sugar. This is because when the reaction has taken place between sodium carbonate and hydrochloric acid, which forms sodium chloride and water and above carbon dioxide gas. NaCO3 plus, for balancing the equation we should write here 2HCl. NaCO3 plus 2HCl gives rise to 2NaCl. 2NaCl plus H2O plus CO. This is the balanced equation. Here sodium carbonate is an example of metal carbonate. Instead of sodium carbonate we can take any one of them, either potassium carbonate or cesium carbonate. But we generally consider sodium carbonate. When sodium carbonate reacts with hydrochloric acid which evolve carbon dioxide gas. So how can we prove the evolved gas carbon dioxide? Because we have used here calcium hydroxide. Calcium hydroxide is lime water. This lime water turns to milky white. Why does this lime water turns to milky white? This is because the evolved carbon dioxide is reacts with calcium hydroxide. Evolved carbon dioxide reacts with calcium hydroxide, that is lime water, which forms calcium carbonate, CaCO3, which is precipitate. Here downward arrow indicates precipitate shell. CaCO3 plus H2O, water. So this lime water turns to milky white. This is because the reaction has taken place between lime water and carbon dioxide forms calcium carbonate, that is a precipitate. That's why this lime water turns to milky white. This is the way we can test the evolved gas is carbon dioxide, or in another way we can also test the evolved gas is carbon dioxide. When you place burning matchstick near the mouth of the delivery tube, then the burning matchstick put off or it extinguished off. This is because the nature of carbon dioxide is carbon dioxide acts as fire extinguisher. That's why when you place burning matchstick near the end of the delivery tube, then the burning matchstick fire puts off. That is the nature of carbon dioxide. So here metal carbonates reacts with acids which release carbon dioxide gas. Now repeat the activity by metal bicarbonates. Metal bicarbonates like sodium bicarbonate or sodium bicarbonate. NaCO3 is sodium carbonate. This is an example of metal carbonate. Metal bicarbonate or metal hydrogen carbonate example is sodium bicarbonate, NaHCO3. Now replace sodium carbonate by sodium bicarbonate solution. And whenever the metal bicarbonate like sodium bicarbonate is reacts with acid like hydrochloric acid, which form sodium chloride, water and above carbon dioxide gas. So NaCO3 is sodium bicarbonate, that is an example of metal bicarbonate. NaCO3 plus HCl gives rise to NaCl plus H2O plus CO2. Here the evolved gas is carbon dioxide. So in both the cases, metal carbonates and metal bicarbonates reacts with acid and produce carbon dioxide gas. Remember children, in last activity we have discussed acids reacts with metals, evolve hydrogen gas, and bases reacts with metals, evolve hydrogen gas. Here metal carbonates reacts with acids, evolve carbon dioxide gas. Metal bicarbonates also reacts with acids and evolve carbon dioxide gas. So this activity proves the metal carbonates and metal bicarbonates reacts with acids and produce carbon dioxide gas. This is the activity of metal carbonates and metal bicarbonates reacts with acid. Here we have seen calcium hydroxide reacts with carbon dioxide to form calcium carbonate. When excess amount of carbon dioxide is passes through the lime water, then what will happen? Let us see. When excess amount of carbon dioxide gas is passes through the calcium hydroxide solution, it forms calcium bicarbonate. Let us see the equation children. CuOH twice plus aqueous carbon dioxide. When excess amount of aqueous carbon dioxide passes through the lime water, which forms calcium bicarbonate. CaHCO3 twice. Calcium bicarbonate. Let us verify the equation. Ca, one Ca atom. Hydrogen atoms here, two hydrogen atoms here. Here 2, here 2, 4 hydrogen atoms are there. Next oxygen atoms here. 3 2s are 6 oxygen atoms are there. Here 2, 4 plus 1 5. So write here 2. Here 2 oxygen atoms. Here 2. 2 plus 2 4. 4 plus 2 6. Here 3 2 plus 6. Here 6 oxygen atoms. Calcium atom balanced. Oxygen atom balanced. Carbon atoms. Here carbon atom 1. Here one carbon atom is there. Here C2, 2 carbon atoms are there. So let us write here 2. CaOH twice plus 2H2O plus 2CO2 gives rise to CaHCO3 twice. Ca, one calcium atom. Hydrogen atoms are here 2, here 4 plus 2 6. Here 2. Right here 2H2O. Oxygen atoms here 4 plus 2 6 plus 2 8. Here 6 oxygen atoms and here 2 oxygen atoms, 8 oxygen atoms. Next hydrogen atoms here 2. Here 4 plus 2 6 hydrogen atoms. Here 2 hydrogen atoms. Here 2 2s are 4 plus 2 6 hydrogen atoms. Next carbon atoms. 2 carbon atoms are here and here C2, 2 carbon atoms are there. So carbon atoms also balanced. Calcium atom, one calcium atom here on the RHS side, one calcium atom is present. So when excess amount of carbon dioxide is passes through the aqueous, lime water, which forms calcium bicarbonate, CaHCO3 twice. Here calcium bicarbonate is a solution and leaves water molecule. So this is reaction of metal carbonates and metal bicarbonates with acid. Now let us talk about reaction between an acid and a base. Reaction of acid and base. So let us take sodium hydroxide solution. So how can we prepare sodium hydroxide solution in the laboratory? Take few grams of sodium hydroxide in a test tube or in a boiling tube. Add few ml of water to that. Then we get approximate concentration of sodium hydroxide. Now add few drops of indicator, that is phenolphthalein indicator. So when you add few drops of phenolphthalein to sodium hydroxide solution, then the sodium hydroxide solution turns to pink in color. Now slowly add hydrochloric acid dropwise to the sodium hydroxide solution. So initially the sodium hydroxide solution is colorless, but when we add phenolphthalein indicator, the solution turns to pink color. Now when we add dilute hydrochloric acid but dropwise to the sodium hydroxide solution, after some time the sodium hydroxide solution changes from pink color to colorless. This is because hydrochloric acid is an acid, sodium hydroxide is a base. In basic medium, phenolphthalein indicator as pink in color. So when we add dilute hydrochloric acid dropwise to the sodium hydroxide solution, there is a reaction has taken place between sodium hydroxide and hydrochloric acid, then which form new substance. The chemical reaction has taken place between sodium hydroxide and hydrochloric acid, that is an acid and a base. It forms new substance. That is the reason why the color changes from pink to colorless. Now when we add phenolphthalein indicator to the solution which contains both sodium hydroxide and hydrochloric acid, which doesn't show any color, because in this case volume of or concentration of hydrochloric acid is more. Now again we add few drops of sodium hydroxide to the solution which is present in the test tube. Now the solution again changes to the pink color. Now when we add hydrochloric acid dropwise to the solution, then the solution again changes to the colorless. So this activity proves that the reaction between an acid and base takes place. The reaction between acid and base to form salt and water. For example, hydrochloric acid is an example of an acid, sodium hydroxide with base. And the reaction between hydrochloric acid and sodium hydroxide, that means acid and base to form salt, that is NaCl, and forms water. So when we add few drops of phenolphthalein, indicator to the sodium hydroxide, which changes to the which color? Pink color. For our convenience, let us add 2 drops of phenolphthalein indicator to the sodium hydroxide solution. We have taken 5 ml of sodium hydroxide solution. 5 ml of sodium hydroxide solution which is present in pink color. Right? And we are slowly adding hydrochloric acid by dropwise to the sodium hydroxide solution. So initially there is no change in the pink color of the sodium hydroxide. But after some time the color of sodium hydroxide changes to colorless. So let us say, for convenience, let us consider when we add 5 ml of hydrochloric acid to the 5 ml of sodium hydroxide, then these 2 solutions neutralize each other, because it is a base and it is an acid. The reaction between acid and base to form salt. Salt is a neutral substance. So which form neutral substance? And the reaction between 5 ml of hydrochloric acid is completely reactive or completely neutralizes 5 ml of sodium hydroxide. Then the solution changes to colorless. Then neutralization reaction has taken place between acid and base. That's why acid-base reactions are also called as neutralization reactions. Because the reaction between an acid and a base to form salt. Salt is nothing but neutral compound or neutral substance. Neutral substance is the one of the product of neutralization reaction. That's why the reaction of acid and base is a neutralization reaction. That is the reason why when 5 ml of hydrochloric acid is added to the 5 ml of sodium hydroxide, the color changes from pink color to colorless. Then acid neutralizes the base. This is called neutralization reaction, also called as acid-base reaction. When you do the activity with another set of acid and base, that is sulfuric acid, H3SO4, and base potassium hydroxide, which forms potassium sulfate. K2SO4 is potassium sulfate plus water, H2O. Let us verify the equation children. H2, here 2 hydrogen atoms, here 2, 2 to the 4. Here 2 to the 4 hydrogen atoms. 1 sulfur atom, 1 sulfur atom. Here 4 oxygen atoms, here 4 oxygen atoms, here 2, 6 oxygen atoms. Here 4 oxygen atoms, here 2 into 6 oxygen atoms. Hydrogen atoms 2 here 4, here 2 plus 2. Yes, it's a balanced equation. Here sulfuric acid is an acid, potassium hydroxide is a base. To form K2SO4 is potassium sulfate. This is salt plus water. Here acid and base neutralize each other, which forms salt and water. This is an example of neutralization reactions, also called as acid-base reaction. So this is today's session, children. In today's session, we have discussed about reaction of metal carbonates and metal bicarbonates with acids. In that experiment, they release carbon dioxide gas. When metal carbonates and metal bicarbonates react with acid, evolve carbon dioxide gas, because carbon dioxide is a fire extinguisher. Next activity, reaction of an acid and a base. Here, whenever an acid and a base react together to form neutral substance, that is salt and water, is called neutralization reaction. I hope you understand today's session, children. We'll meet in next session. Thank you.